widely accepted metric for characterizing glycemic variability. MAGE, M-A-G-E, is a paper by Service in the, I think in the late 70s on that. And that's been used all the way up until very recently. More recently, people have realized that in addition to the amplitude of oscillations, the frequency of oscillations is also a critical factor, and it's a critical risk factor for severe hypo events, and also, frankly, for DKA. There's also a paper by Penkoffer, Penkoffer, and colleagues, who talked about how the quality of life associated with high glycemic variability. That's often neglected, but patients with diabetes who have high levels of glycemic variability, as measured both by the frequency and the amplitude, they feel bad. There are other papers. There's a paper by Whitelaw. There's another paper by Kovachev. There are a couple of papers coming out that have been written by Earl Hirsch and others that look at high glycemic variability and show that it's correlated with high rates of change of glucose. And people feel bad when they have high rates of change of glucose. They feel slightly nauseated. They feel odd. They become irritable. So there's this whole movement in recent years to expand the way we look at glycemic variability to take into account not only the amplitude of the oscillations, which was first studied by Service and first captured in the MAGE metric, but now to also look at the frequency or temporal component. In fact, that's really the subject of the Kovachev-Kobeli paper from the fall, and is the subject of a couple papers that will be coming out soon with Earl Hirsch and Bruce Buckingham, among others, that look at that temporal component. So there are a number of new metrics that are about to come out that I think are going to be proved to be more useful in characterizing the way we think about glycemic variability in subjects with type 1, and for that matter, type 2, if that helps.
Yeah, that's very helpful. Thank you for all the details on those. And getting back to the use of CGM devices as a way to bring in this data, I'm curious what CGM devices perhaps you've used in clinical trials before. Again, for the purposes of the project, if you're able to comment on specific models or devices and important differences as it relates to a clinical study, that would be helpful.
Yeah, there have really been great differences over the years in the accuracy and reliability of CGM devices, but that is lessening now. There's new work from the group at Medtronic MiniMed, which is the results of their pivotal study on what they used to call the Enlite 3 sensor. It's hard to keep up with their marketing. It may be now called the new Guardian or Guardian Connect or something like that, but it's their next generation sensor, and it seems to have a comparable level of accuracy and reliability to Dexcom G4 and G5. So there are three that are commercially approved in the United States. Well, three that are commercially approved in the United States. The Dexcom G4, G5. So those sensors are actually the same. The sensor material is the same. The algorithm is the same. One is the difference between the G4 and G5 is that one has a transmitter that uses a proprietary radio link to a custom handheld receiver for the display of the data. The other uses a Bluetooth link that can go either to a handheld receiver, which is a medical device, or to a phone. So the G5, the new G5 transmitter approved by the FDA can be displayed on an iPhone, and a lot of people find that very useful. And the accuracy there is characterized by the average error or mean absolute relative difference, and it's typically around 10 to 11%, which is what Dexcom reported in their pivotal studies. There are a number of papers that they published on that.